You've identified a few articles relevant to your research through a search or through your mentor. Now what? How do you get the information you need? Well, first, make sure you know what you're looking at. Start with this question. Are the articles peer-reviewed or not? Peer review is a process where all scientific articles are sent out to 2 or 3 other scientists who review the article and provide comments to the editor about the research. Was the study thorough? Are the interpretations reasonable? Is all of the data clear? While peer review doesn't guarantee an article is accurate, it provides some measure of the rigor of the science behind the article and the validity of the findings presented. This doesn't mean you should never use material that isn't peer-reviewed. Sometimes articles written by journalists instead of scientists provide helpful background on a topic, especially for students just entering a field. Or sometimes scientists publish raw data or information that hasn't been peer-reviewed on their websites. This may be useful, but you should make sure you understand what you find. If you've narrowed your search down to a few research articles, understanding how they're constructed can help you decipher them. Research articles can have several sections, usually an introduction section, methods, results, and a discussion or conclusion section. Depending on why you're reading the article, you might skip to one section or another. But what are these parts? The introduction sets the scene. Why was the research done? The authors will often describe big questions and the gaps in our understanding that motivated their work. This section of an article is a great place to learn what's already known, all of the work that's led up to the current research. If you're just getting started in research, it's often the most helpful section. The methods section provides details on how a specific experiment or study was conducted. It's critical that scientists carefully document their methods so that their work can be evaluated or reproduced. So understanding how someone did a study and exploring how to extend or modify it is a key part of this process. Also, providing detailed methods allows for other scientists to verify one's work, and this is critical since science is self-correcting. However, if you're just getting started, you might not need to read the methods section in depth right away. The results section of an article presents the data. This section most commonly contains graphs, tables, pictures, or other representations of data. While it also provides an analysis of the data, models that seem to fit the data, or other calculations, it stops short of providing interpretations. This allows other scientists to see the data in an unbiased form and reach their own conclusions. The personal interpretations the scientists bring to a study are reserved for the discussion and conclusions section. Since interpretation often draws on experience and background, it's commonly separated out into a separate section. When I come across an article I'm interested in, I look at the title and read the introduction, then I skim through and look at all the figures, and then I read the conclusions. I might decide to go back and dig in and look at the results section a little bit more carefully, or maybe the discussion, but I rarely read an article straight through from front to back like a novel. This is a great way to get information that's most relevant as quickly as possible. Scientific articles can be very technical, and it's easy to get confused by complicated terms in a paper. However, this doesn't mean they should be poorly written. It's easy to forget that, as in everything, some articles are better written than others, and the reason you may be having trouble understanding one article or another may not be your fault. It might reflect the article itself. The standard format of scientific articles makes them easier to navigate, but if you ever have a question about an article, it's a good idea to ask your mentor or a colleague in the lab what she or he thinks. A different perspective can help you better understand the research you're reading, and you may find that they have the same questions as you.